get started, before I get started, I do want to say that, you know, I guess as kids, we want to grow up to be firemen, grow up to be president, grow up to be whatever. And I'm not sure I've ever been president of anything. I thought I could be president of the hair club for men at one time. But it has been an honor and a fun privilege to serve this organization in that capacity for the past 2 years, and I appreciate the opportunity to do so. Thank you all very much. So, let's get into this telescope business. So this was supposed to be Jeremy Belton's presentation, and he realized 2 weeks ago that this Christmas party conflict was coming up. So I said, well, I can do this first half for you. So he sent me this presentation, and then thank you. You want to get a seat before I start goofing with the lights, because I always get them wrong. Suddenly it might go dark in here. Wrong. How do you think you get that wrong? Oh my God. Everyone's done. Why don't let's go out?
That? There?
That's the first time I've ever seen that.
You probably won't. No.
Nope.
Nope. What?
How bizarre is that? Wait a minute, I found it.
Oh.
Where is it, just for future reference?
It's this big thing up here with no plate on it and no knob. There's little stick sticking out of it. All right. So, I've done this presentation probably 5 or 6 times over the last 20-something years as a member, and it's always about the technical ins and outs of telescopes, what's the differences, and I thought this time I might take a little different approach, and it's kind of along the vein of do what I say, not what I do, advice for telescope buying. I'm going to describe to some extent the process I went through to buy my first telescope and demonstrate all the wrong things about that. Before I do, we do have on our YouTube video, on our YouTube channel, Jeremy has spent a lot of time this last year creating YouTube videos for the Memphis Astronomical Society YouTube channel, and there's some great ones up there about telescopes of different kinds, how to use them, how to use binoculars for observing, doing solar observing, astrophotography, and there's a great looking picture that's done by Keith back there. So we got some chops, you know, we know what we're doing. This is my first telescope. I got interested, I actually was not that interested in astronomy as much as I was an amateur photographer, semi-professional. I got paid for doing some weddings and stuff. And just optics in general always fascinated me. I've had terrible eyesight all my life, so anything that could help see further or what have you was just fun. So I wound up picking up a Casco 4.5-inch Newtonian on an equatorial mount at the Sears outlet store. years ago for about a third of the price, you know, so it was a heck of a deal. But there are lots of reasons why these wind up in the attic. And that's exactly what happened with mine. After about 2 or 3 months of playing with it, I could go into the long list of things, the eyepieces, the mount was not sturdy, the magnification. They were selling this like they try to sell stereos, you know, the number of watts, you know, is the power of the stereo. It's got nothing to do with whether they sound good or not. Just get lots of watts, right? Lots of magnification. This is absolutely the wrong thing to buy a telescope over. So this is the ad for them back then. But then in the early 90s, there was a comet that was known was going to crash into the planet Jupiter too, and we had a 2-year warning, right? And I thought, that's never happened before that we knew of, you know. And here was probably once in a lifetime opportunity to watch something happen in our own solar system, in my own backyard with my own telescope. So I got that 4.5 inch out and started playing with it and trying to use it, looking at Jupiter, see if I could see enough detail to be any good, and I just wasn't happy with it. And I started trying to buy eyepieces for it and those things, and it just wasn't panning out. So I thought, well, I'm willing to invest some money in a better telescope. So I started studying telescopes, buying magazines, astronomy and SkyTel and what have you. And the more I looked in there about telescopes, they really fell into 2 categories. You'll notice this later in the slides. Jeremy will tell you that they fall into 2 categories, reflecting and refracting. And that's true, but in a more basic sense, as far as I'm concerned, they fall into 2 categories: long focal length and short focal length. And if you're a photographer, that means something to you. If you're not, what that means is long focal length lenses are for taking pictures far away and high magnification. But short focal length gets you much wider fields of view. Now here's where it gets contrary to what you might think. If you think that for planets, they're closer, right? They're in our own solar system, so I don't need to see so far away. And for other galaxies and stuff way, way out there, I really want to see further away, so I might want higher magnification. Well, it turns out that's exactly opposite of what you should do. Long focal length, high magnification works great on planets because they're so much brighter than the things that are way far out there, what I've come to call the faint fuzzies. You know, they're galaxies, nebulas, clouds of gas and stuff, star clusters. They're so far away that you really need to gather as much light as you can. And the wider this bucket, the wider the mouth on that funnel, the more light you can get into the bucket. And that's the real idea that you're trying to achieve. So I started studying telescopes, and it turns out that Parkes made a telescope that does both. It's actually, if you change the secondary mirror, you go from a Newtonian reflector, this is where the eyepiece is for a reflector telescope, or it goes into a Cassegrain mode, where the eyepiece goes back here at the back end of it by changing the secondary mirror. I thought, perfect. That's it. One telescope that does them both, right? So I wrote off to Parkes and got a price sheet from them, because I never put the prices in the magazines back then. And this one, the small one, was $8,500. And I thought, okay, that ain't happening. And of course they went up from there. Well, it turns out, and this is how I knew I was doomed to astronomy. So I see this, and not a month later, After the Sears outlet store closed, I've always worked around the airport. I worked at FedEx for 30 years. I worked at an engineering company that had offices near FedEx before that. And so there were a lot of pawn shops and stuff down there. And I used to buy tools and stuff from pawn shops. And every now and then, go shop the pawn shops at lunch, see what's there. I walk into a pawn shop, and that's sitting there. And I'm sitting there going, I wanted to do that Snoopy dance and jump around and go, oh my God, I can't believe this. And I walk up to the guy and said, what's that? And he says, well, it's a telescope. It belongs to the guy next door that owns the bug extermination business. He's trying to sell it. We thought we'd let him set it up in here, see if he can sell it. I go next door and talk to the guy. Long story short, I bought this telescope, an 8-inch orange tube Celestron, a couple spotting scopes, some other miscellaneous junk, and a trailer to haul it all in for $2,200. Yeah, and so this was my second telescope. All right, absolutely wonderful instrument. I cannot tell you the countless hours I spent looking at planets through this thing. But as you might get, that tube, that's steel tubing, right? This thing altogether weighs a little over 300 pounds. So it takes an hour to set it up, an hour to take it down. So this was taking this out to the country real quick where it's dark to do some casual observing was not the best use of time and energy. I had this telescope for 20 years. I sold it maybe 3 or 4 years ago. About 2 or 3 years after I bought that other telescope, though, Aperture Fever sets in. Now, if you've ever owned a telescope, this is one of those cases where bigger is always better. Everything else being equal, bigger is better. And it has to do with how much light you can capture. The bigger the objective, the bigger the mirror, the more light you can gather, the better you can resolve the image. Bigger is better. And so this 13-inch Coulter Dobsonian came up. A friend of ours, Ben Hudgens, had this, and it was too big for him to get in and out of the back seat of his car. So he offered to sell it to me for what he bought it for, which was $500. And this is a 70s, mid to late 70s vintage Dobsonian or a Newtonian reflector in an alpha-azimuth mount. I added the electronics. This tells me what it's pointed at. My iPad will tell me exactly what I'm looking at, and this is a heads-up display finder, and this is the eyepiece for it. This is, to this day, my favorite telescope. This goes in the back of my pickup truck and goes out in the country easy. It takes 10 minutes to set it up. I'm observing in a half hour. It takes longer for the optics to cool down. And that's something else we'll talk about maybe in January, is that you take a telescope out of the hot indoors, carry it outside and plop it down in the cold outside, and it won't be ready for observing for another hour, hour and a half. The glass needs to be the same temperature as the outside air. There's lots of reasons for that, but so this one, the longest thing you got to wait for this is for the optics to stabilize. But the views of this thing are outstanding. I've also since purchased a go-to mount and a carbon fiber 8-inch Retracting telescope. This thing makes beautiful pictures. Looking through it is horrible. Retracting telescopes are expensive. They're very nice, sharp, crisp image all the way to the edge of the field of view. But central obstruction is so big that it's just going to make it horrible to look through. This, on the other hand, is a 10-inch Schmidt Cassegrain that I use on that same mount for visual observations. This is a 90 millimeter. This telescope is just fun. This is I use for solar observing. But what's cool about it is truly a go-to telescope. You just set it down, turn it on, tell it. What do you tell it? You don't tell it anything. You just turn it on. It figures it's got GPS in it. It's got a compass in it. It's got a level in it. It figures out where it's at, what time it is, what day it is, and starts pointing at things. And all you got to do is fine tune it a little bit, and then it's ready to go point at whatever you want to. That's the only reason I had it. Once you spend a lot of time looking through big aperture telescopes, this is good for planets and solar systems and the sun. But faint fuzzies, I'll get my big telescope out. But it's fun to play with. This is the telescope I used to shoot the solar eclipse with, just because I had a camera adapter for it. 2 years ago, if you'd have asked me if you should use an off-the-shelf spotting scope for astronomy work, I'd have told you, don't waste the money. I picked this up in an estate sale where I bought 3 pairs of binoculars and 2 or 3 other spotting scopes and some other stuff. I bought all of it at once. In fact, I got this in that estate sale as well. This is a 100 millimeter Celestron spotting scope that is actually very, very good, especially for planetary work. I'm amazed at it. So, and all that's to say, if you go at this like me, you can spend lots of money and in 25 years own about 6 telescopes, 7 telescopes, and be president of the Memphis Astronomical Society. All right, so let's get back to the 2 basic types of telescopes, reflectors and refractors. Refractors are the ones with the glass lenses that the light comes through to begin with. Reflectors all use mirrors and maybe some lenses. The purpose is to gather light, so the bigger the light, the first element in that optical system is, the more light it can gather, the better resolution the image can be. We're not about trying to magnify. Magnification is as overrated in optical systems as watts are for a stereo. Simplest telescope in the world is your own eye. You've got a lens that's focusing an image on the retina. The trick about the eye, and this is why pictures most cameras cannot take pictures as good as what you can see. This is why taking pictures of dark stuff is incredibly difficult. And it's because of this little thing right here, right? This a remarkable image processing computer called the human brain. What you're seeing, there's a whole other science in that. What you think you see is not necessarily what's there. It's how your brain's able to process it and a whole lot of other information to make the image. Total collecting area of a telescope, again, it's about the size, it's the diameter of the objective. In most telescopes, when I said my dial was a 13-inch, that's the diameter of the primary mirror. There are some telescopes in advertising that when they talk about the first measurement they put out, like 1200 millimeter is the big number, and that's the focal length. It's not the diameter of the objective. So be careful about just picking big numbers. Size does matter. The refracting telescope was invented by a guy named Hans Lippershey. He was a Dutch glasses maker who, as the story has it, that a couple of kids in his shop figured out that they could make something look closer if they held 2 lenses up and worked them together. And he took that idea to the patent office and tried to get it patented. He didn't actually ever get the patent, but the Dutch government thought enough of it that they paid him a lot for it. Turns out the patent office had a lot of claims that other people had that idea first, and it probably were valid claims. But anyway, by the time it got to Galileo, he improved on the design, and Galileo was the first person to document using a telescope to look at the night sky, to look at celestial objects. And his first book about it were a lot of drawings of the moon and details that no one ever believed were really there. So that's why Galileo is the father of modern astronomy. The Galilean telescope uses a convex lens to condense the rays of light, and then a concave lens set to straighten them back out. You can't focus on this converging light beams. It's just human eye is not designed to do that. So those light beams have to be straightened back out for you to be able to focus on it. And that's not how most of them work today. But this is the original refracting telescope design. This is what his telescope looked like. It was very small. But of course, most of his work originally was on the moon, which if you try to look at that through a big telescope, it will blind you anyway. This is a typical refracting telescope. Limitations of, and this were the first telescopes, and what they found as they started making them bigger and bigger is that there were some fundamental limits to what you can do with glass. Turns out that to make these telescopes glass lenses very big, they started getting thinner and thinner at the outside edges, and you got glass that gets about this thick in the middle, and you're holding it by something about that thin at the outside edge, and glass is not actually considered solid anyway. It's considered a superfluid or
A very viscous fluid.
yeah, it's a very viscous fluid. So they will sag, and so that's not good for optical systems, mirror sagging. Then to make them long focal length, the tubes that they were in is very heavy glass at one end. Those tubes sagging was a problem. The largest reflector in the world is this one. This is a 40-inch, and if I recall, there's actually a flaw in the lens. I think there's a chip out of it or something, but this has remained in operation. I don't know if it still is today. There's a lot of light pollution near this observatory anymore, so it's not very useful. You see how long that telescope tube is? And that's all steel tubing. It's a 40-inch lens up there, and that again is the biggest they get. Most modern telescopes are reflecting telescopes because they can be bigger. So instead of lenses, they use mirrors, and the beauty of using a mirror is that you can make the mirror thinner. Doesn't have to be as thick as glass lenses, but you can support it even in the middle from behind. And that was the big breakthrough in reflecting telescopes, the ability to support a big piece of glass from behind. I can go. Some of this is more talking about modern. They are reflectivity of mirroring is not 100%. If you, in fact, I don't know that there has ever been a 100% mirror ever made. The best telescopes have got something on the order of 97, 98% reflectivity. Some light does seep through mirroring. So and that's another, optical systems are all a compromise. The more lenses you put in a system to correct for image issues, the more loss you get. Every lens creates loss. Every surface that the light bounces off of or passes through creates loss. This is a, okay, this is the Gregorian reflector. And this reflecting telescope used a, did he do, I think these were spherical mirrors, and the main mirror back here would reflect back to a secondary concave mirror, and then back out through the middle for the for an eyepiece. The Newtonian reflector is the most common reflector telescope. This is probably telescope-wise, Newtonian reflectors are your best value for the amount of money you got to spend for the amount of aperture that you can buy. And this is where you've got a parabolic mirror reflecting to a flat secondary and then reflecting the beam of light outside the path so that your head's not in the way when you try to look at it. This is the very early, this is Newton's a model of his second reflecting telescope. It was focused by adjusting the length of it. This is Jeremy's 20-inch Newtonian reflector. All right. This is a very nice telescope, and just shows you kind of how big they get. And mine's a 13. This one is what's called a truss tube telescope. So this, he's got a shroud on here right now, but this structure up here for holding the eyepiece and the secondary mirror is held up there by a set of open tubes. This shroud is just there to help keep stray light out and keep the image more higher contrast to the image. But this is the kind of Newtonian reflector I want. You know? where you crawl into the secondary mirror and look at it and sit down in a chair and look at what's coming back at you. So that's cool. In fact, this is the 5-meter Hale telescope at Mount Palomar. This was built in the early 1900s, and when was it?
It first light in 1948.
48.
Yeah, it was under construction during World War II, so they had to
stop it. Yeah, right. So this is where the camera was, and they'd sit there and they'd put glass plates like film into this holder and take images. And the astronomer would sit here all night long as this thing tracked whatever he was taking pictures of. It was also a very cold job, as I recall. This is Cassegrain Reflector, another telescope, my second telescope, the one that would be either a Newtonian or a Cassegrain Reflector. This is the mode it operated in. You had a parabolic primary and a hyperbolic secondary mirror. The beauty of that telescope was it would go from an f3 focal ratio of f3, which is very short, Newtonian, to a focal ratio of f13, which is very long, and for a Cassegrain. And it was really a one-size-does-everything telescope. It would take wonderful wide field images and excellent planetary work. This is an example of an 8-inch Schmidt Cassegrain. These telescopes. The difference between a regular Cassegrain and a Schmidt Cassegrain is that they do, these mirrors are hard to make, and there is still some, if they're using a spherical mirror instead of a parabolic mirror, you can correct for that with a corrector plate in the front, and that's what they do in Schmidt Cassegrains. This is an 8-inch Schmidt Cassegrain in a fork mount. This is a, I think 4-inch.
That is Maxitop.
Yeah, but it's a 4-inch, right? It's 125.
125.
125.
It's 5 inches.
And this is a Maxitop. They're different in that the Maxitop uses the portion of the corrector plate to be the mirror for the secondary. These are usually, both of these generally produce very sharp images. They're always pretty nice. They're also rather expensive. All right, refracting telescopes limited to small diameter, best for small bright objects. Reflectors, if you're interested in galaxy hunting and faint fuzzy objects, big reflecting telescopes are your best friend. Schmidt Cassegrains, their two will cover just about everything well. They're typically relatively long focal length, f10, f9, but you can use compression lenses that'll get them down to the f5, f6 range. Then buying telescopes, there are, and I'll leave some of this for Freddie. I will say that buying used telescopes is still not bad. Most people that have telescopes that want to sell them are either got into it, had more money than they had time or interest, and wound up with a serious investment, sitting around doing nothing, and finally decide to sell it. Those telescopes typically don't have a lot of use. They probably never were really set up correctly, and most of the time in good shape. I haven't bought a new telescope ever, and I've not gotten any bad deals. Nothing that was misrepresented or, and that's, I guess, the thing you got to look at when you're buying used equipment is either know what you're doing or you know, if you're buying online, being careful about
Do not buy on eBay.
misrepresentation. Huh?
Do not buy a telescope on eBay.
Yeah, I'm not sure. I've never bought one off of eBay. There are some out there. The problem with eBay is you've got no idea who you're buying from. Cloudy Nights is an astronomy bulletin board, and they have people buying. They got their own buy and sell operation going on there. Typically, the people there are people that know what they've got, know what they're doing, and just trying to, moving equipment. But they've changed what they want to do, and they're buying a different piece of equipment. AstroMart is a similar situation. They're another website that's, they do as much. This one's probably more for selling stuff than Cloudy Nights. Cloudy Nights was just a discussion forum at first. AstroMart was always a buy and sell shop for astronomy stuff. And then there are some very good online astronomical companies. OpCorp is one of them. They're one of my favorites. Just deal-wise and helpfulness, about the best prices you can get, about as helpful as anybody. There's some others, there's some smaller ones. B&H Photo is actually very good. They're not as dedicated to astronomy. They're a big photo place.
I usually find these guys know their stuff.
They do.
They know their equipment well, and they give you pretty good advice.
And I've actually got a guy You know, I've got a guy at OpCorp, you know, whenever I call up there to talk about or order something, I call Richard, you know, because he's my guy. And believe it or not, he seems to remember what I've got. I don't know if they've got it all on their computer or what, but they are helpful, so. I think that's it. So, you can have questions, but Freddie's gonna pick this up and go further with it after the break. I'll be glad to answer any questions if you've got them now. We do have at least somebody brought some equipment that, outside that they're looking at selling. We have looked at it and the pricing looks very nice, very good, reasonable, and it's a good thing I'm broke, or still, that wouldn't be out there for sale. Come back after the break and we'll do some more. Thank y'all very much.